Okay, welcome back. This is benchmark number 25. We're continually talking about quadrilaterals, and specifically we're talking about parallelograms. So let's just go ahead, let's move me around a little bit. Okay, right there. Okay, so in this particular example, we want to go ahead and look at some more properties of parallelograms, and specifically we're going to talk about diagonals. So let me go ahead, give me a second or two. So if a quadrilateral is a parallelogram, that's our key word right there, then the diagonals, they have to bisect each other. And you guys remember what bisect means? Hopefully you can draw that from the past. So here goes my diagonal from A to C and B to D. So what happens if they bisect each other and it's a parallelogram, we're going to say that AP is going to be equal to PC. And we're also going to say that DP is going to be the same thing as PB. All right? That's if a quadrilateral is a parallelogram. Those diagonals are going to bisect each other perfectly and cut it in half. All right? Any questions, let me know. Thanks. All right, here we go again. Benchmark number 25. We're going to talk about, once again, if this quadrilateral is a parallelogram. If it's a parallelogram, we know that this side and this side is parallel. We also know that this side and this side is also parallel, and they're also congruent. So if it's a parallelogram, then each of the diagonals separates the parallelogram into two congruent triangles. Therefore, what we'll see here is, here's my reflexive property. Angle A, angle C are going to be congruent. Angle ABD will be congruent to angle CDB. And we'll also say that angle CBD will be congruent to ADB. So the key here is that if it's a parallelogram, one of the diagonals will separate into two congruent triangles. All right, let me know if you have any questions with this. All right, this is example 2 for benchmark number 25. All right, let's go ahead. Let's read this very carefully. All right, let's continue this example. Let's go ahead. We want to find the letter R in this case. So I'm going to locate this in my parallelogram. All right, so it's right over here, 4R. It's going to be the segment WX. And we also know some things about parallelograms, some properties. We know that WX is going to be equal, or going to be congruent to angle, or I'm sorry, from side ZY. So we know that WX is 4R, so I'll substitute that value in based off one of those properties of parallelograms, and we know that ZY is going to be 18. All we want to do here is solve for R. Let's do the inverse of multiplying. And 4 goes into 16 4 times. I got 2 remaining. So I'm just going to go ahead and punch this in. 4.5. And it doesn't have any unit of measure, so 4.5 is going to be side R. Let me know if you have any questions. Thank you. All right, I'm getting into this. Benchmark 25, example 2, letter B. If WXYZ, if it's a parallelogram, I know a lot of properties for parallelograms right now. Again, you should be looking at your notes. You should probably be rewinding this video. Make sure you understand these properties of parallelograms. We want to go ahead and find the value of S. So let me locate this S. Okay, S is right here. That references to this segment from X to that place where it intersects these two diagonals. And There's another S value over here. So some things I notice about this particular problem is I have 7s plus 3 for this segment, and I have 8s over this segment. So I know that they bisect each other perfectly. I know what bisect means, that they both have to be the same. So I'm going to set this easy equation up. 7s goes plus 3 equals 8s. Easy to solve. You can do this in your sleep. Let's collect the terms. I got a 7s on this side of the equal sign. Let's change it. Let's bring him over to his other friend. Minus 7s. Minus 7s. Lovely. 7 minus 7 is 0s. Bring down that positive 3. 8 minus 7s is 1s. And my final answer, I can divide both of them by 1, or I can just say s equals 3. That is it. That's done. I'm using the properties of parallelograms. I'm using the property of when the two diagonals bisect each other. It's easy. All right, let me know if you have any questions. Thanks. All right, it's the last question, example 2. Letter C. WXYZ is parallelogram. Find the value of t. So I'm going to locate my t angle here. And let's see if there's any t. There's no other t. What's interesting about this, I have a couple diagonals, but I also know that this angle right here is going to be the same thing as angle 18 because the two triangles are congruent. Since I know that this angle is going to be congruent to this angle, based off the corresponding parts of congruent triangles, I got this. This isn't bad. This is so easy. 2t. Set them up equals 18. Solve for t. Inverse of multiplying by 2 is dividing. Let's go ahead. T equals 9. Anything else I need to find? They just asked me to find t. There it is. T equals 9. Let me know if you have any questions. Up next, you got the guided practice. Again, I always tell you guys this is my favorite part of the lesson. You've been paying attention. You've been taking your time going over the notes. You're getting all the questions correct. Letter A, example number 2 for guided practice. ABCD is a parallelogram. Find the value of x. Locate where that x may be located. Use the properties of parallelograms. You got this. It's either A, B, C, or D. One more time, it's your time to shine. ABCD is a parallelogram. Find the value of P. I'll locate where P is located, and I'll use the properties of parallelograms. Let's solve for P. Is it A, B, C, or D? Let me know if you have any questions. Good luck. Here it is. Last question for the guided practice. This is example number 2, letter C. ABCD is a parallelogram. Find the value of K. Again, I'll locate this. 3K plus 4 is here. You guys know some properties of this parallelogram. If you don't, go back, rewind it, look at your notes, and set this lovely equation up. It should be easy if you set it up. All right? A, B, C, or D. Look forward to seeing a 70% or better on this section. All right.